Pumping systems are used to move liquids, gases, or slurries from one place to another. They are used in a wide variety of industries, including agriculture, manufacturing, and oil and gas production. Pumping stations are facilities that house pumping systems and are typically located at strategic points along pipelines, such as the beginning or end of a pipeline, or at a point where the elevation of the pipelines change significantly. Pumping stations are typically designed to handle a specific flow rate and pressure, and may include multiple pumps and control systems to ensure reliable operation. They are crucial for various industrial, commercial, and municipal applications. These stations are designed to move liquids from one place to another, such as from a water treatment plant to a distribution network. Pump station design is a common community project. Being common, however, should not be confused with being simple. There's nothing like a best design for pump stations. Pump capacity, station type, control strategy, and a multitude of other factors contribute to variations in design. Pumping systems are typically composed of pumps, piping, valves, and control equipment. Now let's talk about pumps. Pumps are the heart of a pumping system, and they come in a variety of types, including centrifugal, positive displacement, and submersible. Centrifugal pumps are the most common and are used for a wide range of applications, including water supply, wastewater treatment, and industrial processes. Positive displacement pumps are used for high pressure applications, such as in oil and gas production. Submersible pumps are designed to be submerged in fluids, such as groundwater or sewage, and are commonly used for irrigation, stormwater management, and municipal wastewater treatment. The selection of the right pump depends on the fluid being pumped, its viscosity, flow rate, head, and other factors. Before a pump can begin to move fluid, it must be primed to remove any air in the pump or suction pipe. This can be done manually or automatically. Identifying the pump capacity and performance is the initial and most important step in pump station design. Now, let's look at motors. Pumps are usually powered by motors, and the motor's horsepower should be appropriate for the pump's capacity and head. It can be electric, diesel, or hydraulic. The motor should be adequately protected against overheating, overloading, and other electrical faults. Piping and valves. Piping and valves are used to transport and control the flow of fluids through the system. Piping can be made from a variety of materials, including steel, PVC, and fiberglass, and is typically designed to withstand the pressure and temperature of the fluid being transported. Valves, on the other hand, are used to control the flow rate, pressure, and direction of the fluid. The piping network should be designed to minimize frictional losses, and the valves should be appropriately sized and located to ensure smooth flow control. Control equipment. A control system is necessary to monitor and regulate the pumping process. The system should include sensors to measure the flow rates, pressure, and other critical parameters, and programmable logic controllers (PLCs) to monitor and regulate the operation of the pumping system. Sensors can measure variables such as flow rates, pressure, and temperature, and send signals to the PLCs to adjust the operation of the pumps and valves accordingly. Maintenance. Regular maintenance is essential to ensure the reliable and efficient operation of the pumping station. Maintenance activities include lubrication, alignment, inspection, and repair or replacement of worn out or damaged parts. Energy efficiency. Pumping stations consume a significant amount of energy, and reducing energy consumption can result in substantial cost savings. Energy efficient measures include selecting the right pump, operating at the optimal speed, and minimizing flow restrictions. Safety. Pumping stations can be hazardous places, and safety measures must be in place to protect the workers and the environment. Safety measures include adequate ventilation, fire protection, and emergency shutdown procedures. In conclusion, pumps will be the most important items, but they won't function without electrical, structural, and heating, ventilation, and air conditioning components. To enhance efficiency, the relationships between these components must be coordinated. The efficient and reliable operation of pumping stations depends on the appropriate selection of the equipment, proper design and installation, regular maintenance, and adherence to safety protocols.